So this is the review key video for Module 3, Topic 1. This is the second test we took. I'm going to go through this review sheet just like I did the Module 2.3. The hope is that you will then go back and work on your corrections for either the whole thing or for the standard that you need to fix so you can help yourself get a passing grade. Okay, so here we go. So number 1, determine whether a function graphed below is invertible. Okay, it is, hold on, let's get there. It is not invertible, okay, because it does not pass the horizontal line test. I'm going to abbreviate. You shouldn't, but I'm going to because I don't have much space. Okay, number 2. So, before we get to number 2. The vertical line test tests if something is a function. In this case, this is a function, but horizontal line test is to see if something is invertible. Okay, the horizontal line test says that if you have a horizontal line through a graph, it cannot touch more than once, and this one touches twice. So that means it is not invertible. Number 2 is the function invertible. Okay, so all of these are invertible except this one, x to the 4th. Okay, so g of x is not invertible. Okay, because it is an even degree, which means it'll be a graph kind of like the one in number 1. Okay, and it will not pass the horizontal line test. Okay. Okay, for part 3, how can you determine without graphing whether a function is invertible? Okay, you can look at the degree of the function. Evens no. Odds can be invertible. There we go. That should be an I. Spelling wrong. It's kind of right. Okay. All right. So number 4. We want to, for an even function, if you restrict the domain, so we restrict what we're looking at for the function, we can then invert it, okay? So if we do an inverse of this function, we're going to change out the x and the y, excuse me, okay? And we will have x is equal to y to the 4th. We're going to 4th root both sides. So that cancels out, and you'll get y, in this case h of negative 1 of x will equal, right there, the 4th root of x. Okay, and the reason why we can do the inverse of this is because we restricted its domain, to highlight this, to be x has got to be greater than or equal to 0. Okay, since we restricted what we're looking at on the graph, then we can change, we can look at we can invert the equation. Okay, so in this case, for the regular function h of x, which is x to the 4th, the domain is from, make this bigger, negative infinity to positive infinity, and the range is going to be, since it's almost like the graph up at the top here in question number 1. Okay, the range is going to be starting at 0 and going up. Okay, if we restrict its domain to be 0 and bigger, for the inverse, then the domain is going to be 0 to infinity, and the range is going to be from, since we're restricting the domain, it's going to be 0 to infinity as well. And y, as we can see in the next part, if we graph it. So h of x will look something like this. if we restrict its domain to find the inverse, we're only going to have this part. That's what happens when you restrict the domain. The graph looks different. It would cut off half of it. Okay, so we're only seeing the one part. Okay. All right. Here's a function. K of x equals x to the third is invertible. This is what the graph will look like. This is k of x. I'm going to change colors because it starts to look the same for the other graph. If you invert it, it's going to look like this. Here's inverse of k to the x. Okay. All right. For the next one, here's our function. G of x equals x to the sixth. Okay, now we're restricting the domain to make it invertible. So here is the inverse of g. That's what it'll look like. Okay. So in question 7, it says, consider the function f of x equals x to the third, write the domain and range. Well, x to the third is the same thing as number 5, the k of x. Okay, so the domain is going to be from negative infinity to positive infinity, from left to right. The range from bottom to top is going to be the same thing. For f of x equals x to the sixth power, like in number 6, the graph for the domain is going to be from negative infinity to positive infinity. But the range, it only starts at 0 on the x-axis, and it's going to go up to positive infinity. Okay? All right, moving on. To find the inverses of something. To find the inverse algebraically, the first step is to switch out the x and y values. So we're going to flip them to be different. Okay, they're going to switch places. So in number 10, how this looks, the g of x is going to be like the y, so we're going to put x there equals 6y plus 2. And now what we have to do is to find the inverse, we have to solve for y. Okay, so we're going to subtract 2 first. So we have x minus 2 equals 6y. And then the last thing to solve for y is divide by 6. So the inverse is going to be x minus 2 divided by 6. If you put y of negative 1, that's fine, but that negative 1, I'll even highlight it, has to be there. Oh, that's ugly. There we go. The negative 1 part has to be there. All right, number 11. Same idea. We have x is equal to the fifth root of y minus 2. Let's make sure that's a y. There we go. And then plus 1. So now we want to solve for y. First step, we have to get the square root part by itself by subtracting 1. So we have x minus 1 equals the fifth root of y minus 2. Next, to get rid of the fifth root, we're going to raise it to the fifth power on both sides. Okay, so that will cancel out with that. The root and the power cancel out. On the left side, we can leave the x minus 1 to the fifth power just the way it is. And now we'll have y minus 2 left over. And then the last step is to add 2 to get y by itself. And we're just taking that and adding it to the back end of our equation. So we're going to get j, the inverse of j of x is equal to x minus 1 to the fifth power, and then plus 2 at the end. All right, number 12. We have x is equal to 7 over 2 y to the third. Okay, now before we can cube root both sides to get rid of that cubed power on the y, we have to divide or multiply both of the sides of the equation by 2 over 7. That will cancel out this side, and we'll have 2 over 7x equals y to the third. And then we're going to cube root both sides. The cube root and the cube will go away. Be left with y, the inverse of y is equal to the cube root of 2 over 7x. All right. All right, and then lastly, we have f of x. So we're going to put x is equal to 2 times the fourth root of x minus 3. All right, before we can do the fourth power to get rid of the fourth root, we have to divide both sides by 2. So we have x over 2 equals the fourth root of x minus 3. Now that the root is by itself, we can raise everything to the fourth power. So we have x over 2 raised to the fourth power equals x minus 3. And then lastly, to get x by, sorry, that should be a y. My apologies, I missed it. Now to get y by itself, we're going to add 3. We can just add 3 to the end. So we're going to get the inverse of f of x is equal to x over 2 to the fourth power and plus 3 at the very end. Okay, and that is our invert, how to find the inverse. Transformations. This is very simple. Do you understand what it's doing? Since it's on the outside and it is a minus sign, it's going to go down by 9. It's on the inside and minus, it means it's going to go opposite to the right by 9. Plus 3 on the outside is going to go up by 3. And plus 3 on the inside of the function is going to go to the left by 3. So inside is the opposite of the sign, and outside you follow the sign, either up or down. Okay. Okay, so now we have to figure out what is happening. Can we describe the transformations going on in our function? So we have, this is our function we're looking at. The negative sign is going to be a reflection over the x-axis. And the positive 2 is going to go to the left by 2. The next one, since we're multiplying the outside as a vertical stretch, by 3, or so of 3. Okay, the minus 5 is going to go to the right by 5, and the plus 2 is going to go up by 2. All right, and 17 and 18, we're given a function. We want to know, can you write it if we tell you what the transformations are? So it says to go right by 3 units. So we're going to be on the inside of the function. And we're going to go right, so it's going to be minus 3. And then it says up by 2 units. So we're going to go plus 2. So it's going to be f of x is equal to that. Okay. So next one, I'm going to reflect over the x-axis, which means it's going to be negative. Okay, the square root of x. It's going to be translated to the left by 9, which means you're going to be plus 9. And then it's going to go down by 7, which means you're going to be minus 7 on the outside. We're going to put f of x in front of it to make it a function. Okay. Doing the roots. Okay. So, this you're going to need some calculator stuff for. So, what number multiplied by itself, here, let me make this bigger. What number multiplied by itself 4 times goes into 256? And that number is 4. So, the fourth root of 256 is just 4. There's nothing left over. Now, to figure out the variables, we figured how many times does 4 go into 6? 4 goes into 6 once, and there are 2 left over. 4 goes into 8 twice, and there are none left over. So that's the a square is left over inside the fourth root power. Make sure you put the 4 next to it. Okay. For part B, So there's no number there, so that's a square root. So what perfect square goes inside of 12? The answer is 4 times 3 are the factors. The square root of 4 is 2. The square root of 3 is left over. Now, how many times does 2 go into 5? 2 goes into 5 twice, and there's 1 left over. And there's your answer. Number 20. What perfect square goes inside of 16? Oh, no, sorry. We want to write these as powers. So it's going to be fractional exponents. Okay? So the exponent on 16 is 1. So we write 16. The power is 1. The denominator of your fractional exponent is 3. So the power value is going to be your denominator of your fractional exponent. Okay? So x to the 8 over 3 power, and then y to the 2 over 3 power. Pretty straightforward. Okay, here we're going to look at x plus 7y as a whole big thing. Okay, so we're just going to look at it as one term. So we have x plus 7y raised to the 6 over 3 power. The 3 is the denominator of your fraction. And that's all you need to do. You're done. All right, next, solving square roots. You have to check your answers on these. Okay, so the first one, to solve for the square root for x, you're going to subtract 6 from both sides. You're going to get the square root of x minus 1 equals negative 1. To get rid of the square root, you're going to square both sides. So x minus 1 equals positive 1. Add 1 to both sides to get x by itself, and x will equal 2. Now you have to check this answer. 2 minus 1 is 1. The square root of 1 is 1, and 1 plus 6 is 7, not 5. So this does not work. This is a no solution. The one solution it does have doesn't work, so there's no solutions. Okay. Number 22. The first thing we're going to do is we're going to subtract 16. So we have 2 times the cube root of x equals negative 16. We have to get the root by itself, so we're going to divide by 2. So we have the cube root of x equals negative 8. Now we're going to cube this. So the cube root and the cube go away, and x will equal negative 512. Okay, you put that into your calculator. The cube root of negative 512 is negative 8. 2 times negative 8 is negative 16, and negative 16 plus 16 is 0, so this does work. All right, number 23. Divide both sides by 4 to get the square root sign by itself. So we have the square root of x minus 6 equals 2. We square both sides so the square root goes away. We have x minus 6 equals 4. We add 6 to both sides to get x by itself. So x will equal 10. So we got to put this in the equation again. 10 minus 6 is 4. The square root of 4 is 2, and 4 times 2 is 8. So that checks out. Number 24. Okay, we got to get the square root sign by itself, so we're going to subtract 2 from both sides. So we have the square root of x equals x minus 2. Now, since the square root sign is by itself, we can square both sides. When we square both sides, we're squaring the right side as a unit. Okay, so we're doing x minus 2 times x minus 2. All right, the square root and the square root will go away. We'll get x on the left side. Then we have to distribute x minus 2 times itself. X times x is x squared. X times negative 2 is negative 2x. Negative 2 times x is negative 2x again. And negative 2 times negative 2 is positive 4. We're going to subtract this x to the other side to get all the terms over there. Those will go away. When we do that, we'll be left with x squared minus 5x plus 4 equals 0. Okay? What we can do here is then factor this. What two numbers multiply to give you positive 4 and add to give you negative 5? And those would be negative 4 and negative 1. So we solve both of those for x. We have x is equal to positive 4 and positive 1. Again, we have to check and see if these work. If we put in 4, we get the square root of 4 is 2. 2 plus 2 is 4 on the other side, so that one checks off. So check. We put in 1. The square root of 1 is 1, and 1 plus 2 is 3, not 1 like it would be. So this one does not work. So x equals 4 is your only answer. All right. Next, we have, to get the square root sign by itself, we're going to add x to the other side. So we have x minus 1 equals the square root of x plus 1. Now that the square root sign is isolated and by itself, we're going to square both sides. All right, just like with the last problem, we have to do x minus 1 times x minus 1. These two terms will go away, so we're left with x plus 1. If we distribute, x times x is x squared, x times negative 1 is negative x, negative 1 times x is again negative x, and negative 1 times negative 1 is positive 1, equals x plus 1. We're going to get all the terms to the left, so those go away and those go away. So we have x squared minus 3x equals 0, because the ones cancel out. If we factor this, we have x and x minus 3. So x will equal two things. X will equal 0. X equals 0, and it equals positive 3. So again, we put these into the equation and see what we come up with. If we put 0 in there, 0 plus 1 is 1. The square root of 1 is 1. And 1 minus 0 is 1. But that doesn't equal negative 1, so that one does not work. We put 3 in there. 3 plus 1 is 4. The square root of 4 is 2. And 2 minus 3 is negative 1, so that one does work. So the only answer is positive 3. All right. And the last one of this type, the square root sign is already isolated, so we're going to square both sides. So we get 9 equals 2x. Once the square and the square root go away, divide both sides by 2, and x will equal 9 over 2. Okay, again, if you put that into the equation to check it off, 9 over 2 times 2 is 9. The square root of 9 is 3, and that works. Okay. Next type. On the test, there are two things for this. Standard 1.1 and Par Standard 5.3. The 1.1 is, can you just set up the equation correctly? And then standard 5.3 is, can you solve it? Okay, so you'll get a calculator for this. I would highly recommend you have a calculator, because otherwise you're not going to be able to do this. Okay, so some things that we have to look at in this question. Okay, we have the fact that the all right, so we'll read it. Big Ben is a well-known clock in London. Okay, it swings back and forth, and you're given the function t of L equals 2 pi times the square root of L over 32. Okay, and we want to know the time, if the time period is 4 seconds. How do we write this out? So if the time is 4 seconds, we're going to put t of L as 4, and that's going to equal 2 times pi. We're using 3.14 time for pi. Okay, times the square root of L over 32. Okay, just by doing that, that gives you a 4 for 1.1. To do better than that, okay, we have to solve it for L. Now, the nice thing about this is you don't have to do anything until the very end. Okay, as far as the calculations. You don't have to do the calculations as you're going through. You have to do them at the very end. What you're doing up until that very end is just showing what you're doing, but you don't actually have to go through and do it yet. Okay, so hopefully by explaining this problem, you'll understand what I mean. So, just like with the other question we've done in the past, we're looking to solve for L, but that's in a square root sign. So we have to get the square root sign by itself. To do that, the stuff on the outside of the square root sign, the 2 times 3.14, has to be divided to the other side. Let's get that to look like a 1. So we're going to divide 4 times 2 and 3.14. So this goes away and that goes away. Okay, so now I'm going to write it down here. 4 divided by 2 times 3.14. I don't have to do it yet. I'm just showing what I'm doing. Now we have the L over 32. Now, to get rid of the square root sign that's by itself now, we have to square both sides. That goes away. So now I have 4, 2 times 3.14 squared equals L over 32, because the square and the square root go away. And now to get the L by itself, we're multiplying by 32 on both sides. Okay, so L is equal to 32 times 4 over 2 times 3.14, all being squared. Now is when you do the actual calculation. Just put that in the calculator just the way it looks, and you'll get 12.98. Okay? All right, number 28, same kind of idea. Okay, so we're given this equation. We have R. If you look at the question, it says the radius is R is 5 meters, so we have 5 is equal to. Okay, we're trying to find V. We're given pi is 3.14 again. Let's get that cleaned up. There we go. And we're given that 10,000 centimeters. But if you convert 10,000 centimeters to meters, you only have 100. There we go. So that, just doing that part right there, setting up the equation, will give you a 4 on 1.1. If you solved it for V, you would get a 4 on 5.3. Okay, so let's solve it. So now the square root sign is already solved, or is already by itself. So if we square both sides, the square root and the squared go away. And we have, oops, let's put that back on the top. We have 5 squared equals V over 3.14 times 100. Okay. So now, if we want to get V by itself, we're going to multiply the 3.14 and 100 off the bottom of our fraction. So we have V is equal to 3.14 times 100 times 5 squared. Okay, now if we do that in the calculator, V will equal 7,850. Okay. Last one of this type. Okay. We're told the wind velocity is going to be 49.3 meters per second, and that's what the VP is. So we put 49.3 is equal to 5.7 times the square root of 998 minus P. So we're looking for what P is. Okay, so to get the square root sign by itself, the first thing to do is divide by 5.7. So we have 49.3 divided by 5.7. These will cancel, and you're left with the square root of 998 minus P. Now that the square root sign is by itself, we can square both sides. We're just going to show that we're squaring it. We're not going to actually do anything with it yet. So we get 49.3 divided by 5.7 all squared equals 998 minus P. Okay. Now to get P by itself, we have to subtract 998 first. So we have 49.3 divided by 5.7, all being squared, minus 998 equals negative p. Now, we have to get the negative sign out of there, so p is by itself, so I'm going to multiply by negative 1. So that means I have negative 1, and I'm going to put everything else that I've written so far in parentheses. Actually, I'm going to double parentheses that one. Minus 998, close parentheses. And that is what p is equal to. So when you put that all in your calculator, p will be 923.19. All right. I think I've got one more page. Yep, just a few more questions and then we're done. All right, for this particular problem, a lot of this is just a calculator, just figure out some stuff. Okay, or if you're given a graph, figure out where the place is in the graph. So for this, if you're given in question 30, you want to find what is the y value, or the h of x, basically, what is the y value if x is negative 3? So we look at our graph at negative 3 on the x term, and the y value is right there at 0. Okay, so we just got to put down 0. For x equals 5, here's 5 on the x-axis. The point is right there, so the y value is 2. And x is negative 4 is right here. The point is at negative 1. Okay. For the next two questions, 31 and 32, you're going to put this negative 3 or the 5 or the negative 4 in for the x term, and just use your calculator to do it. You just put it right in the calculator the way it looks. Just put in these values. So you put negative 3 in for x, you're going to get 5. Put 5 in for x, you're going to get negative 155. You put negative 4 in for x, you're going to get negative 11. For the next question, the absolute value means that anything that comes out of the absolute value brackets is positive. So for example, negative 3 plus 2 gives you negative 1, but the absolute value of negative 1 is 1. 1 times 2 is 2, and 2 minus 10 is negative 8. So you can do that for the other problems as well. It's just a simple calculator kind of question. It shouldn't be that hard to do. You're just going to plug it in. So the next one will be 4 and negative 6. The last questions deal with looking for which value has the biggest, or which equation or graph has the biggest y value if x is a certain number. Okay, so if x is negative 3, if we look at the questions above, which has the greatest value? Is it the h of x graph? Is it g of x? Or is it f of x? And the x equals negative 3 value that's the biggest is 5 right here. So that means g of x is the biggest. At x equals 5, what's the biggest number? That's the 4 for f of x. And then for x is negative 4, what's the biggest number? The biggest number is actually negative 1 for h of x. And that concludes the key for the Module 3.1 review. So again, please go back, do some corrections from your test. Either just do the corrections for particular standards, do the whole corrections, and then contact me to take